Good day everybody, and welcome to another video with James. Today we are going to deal with trigonometry, but we're going to focus specifically on grade 11 level questions, and special angles and reductions is what we're going to do today. So the first type would be a reduction question with a little bit of special angles in it, but what I wanted to show you today that it can be mixed up, but this is how we do the different types of reduction. So a little bit of knowledge needs to be had here before we go into this. So you guys need to know your cast diagram. You also need to know your co-ratios and then also your negative angles as well as your angles greater than 360. All of this can be found in the James book, but all the notes that you should have from school and from your teachers is going to help with this. So what I'm going to do, this is more just application. What I will do in another video, you will see me going through cast diagram, special angles, reductions, or special angles. You need to know your triangles, obviously. But in another video, I'll explain all the theory. But this video is more application. So what we're going to do is we are going to start by reducing. So the first one is sine of 180 plus theta. That would reduce into a minus sine theta. I'm just going to explain my thought process there. We look at the angle and then we ask ourselves, okay, where in the cast diagram is this? The 180 plus theta quadrant is in the third quadrant, which is known as the tan quadrant. Therefore, sine is negative in the tan quadrant. Therefore, that's why we're reducing it to a minus sine of theta. Remember, your reductions will always end up to be this acute angle here. That is in your brackets, or when we do the reduction for an angle, we will see the acute angle that it's reducing to. Okay, fantastic. The next one we're going to reduce is the sine of 90 minus theta, and that is a co-ratio, everybody. So sine of 90 minus theta becomes cos theta. Co-ratios, stuff that you must just learn off by heart. It's the easiest way. Kind of doing a cast diagram explaining the 90 plus theta, 90 minus 270 plus 270 minus. I feel like over my years of teaching, it actually confuses people a lot more because then they have to remember two types of cast diagrams. So what I normally tell my students, learn your normal cast diagram with your theta, 180 minus, 180 plus, 360 minus, and then just learn your co-ratios off by heart. So whenever you have 90s and 270s in your brackets, you know that they're going to change into the other function, cos or sine. Okay, great. The next one is sine of 180 minus theta, which would reduce into a positive sine of theta. Why? Because the 180 minus theta quadrant is the second quadrant and sine is positive there. Okay, great. All over cos of 360 minus theta, we here now. So if I reduce this, 360 minus theta quadrant is the cos quadrant, therefore being reduced to a positive cos theta. And then tan of 135. I'm going to put this step in just for explanation purposes, but when you get an actual angle with actual values, you can see that the previous ones we've been dealing with all have variable angles. We don't know what the acute angle is, so then we're reducing it to that variable acute angle. But when we have an actual number like this example, we have to reduce it into an actual value. We know what it's going to be. So 135 is in which quadrant, everybody? 135 is in the sine quadrant, which is known as the 180 minus theta quadrant. So we're going to say 180 minus what gives me 135, and that would be 45. I'm going to put that in just so that you can see where I'm getting the reduction from. So now we can just go ahead and rewrite this because the tan of 180 minus 45 isn't fully reduced yet. So let's just rewrite that, cos of theta. And now, tan of 180 minus 45. Now we're going to treat it like one of these. But now the only difference is that we now know what our acute angle is, whereas here we didn't. It was staying theta. So now, 180 minus quadrant is the sine quadrant. Is tan positive or negative there? Tan is negative there. So this would reduce to a minus tan of the acute angle, which in this case is 45 degrees. Okay, so that is the only difference between the two types of reductions. One, you're going to have a variable angle. The other one, you're going to have an actual angle that you're dealing with. Okay, fantastic, cool. So now that everything has been reduced, I can go ahead and simplify. So minus sine theta times cos theta plus sine theta. So what I'm going to do here, let's first change this tan 45. Now, tan 45, using my special triangles, which we also need to know off by heart, everybody, 1, 1, root 2, we now know that tan of 45 is equal to opposite over adjacent, which is 1. So let's first change that. Obviously, for explanation purposes, I'm putting in a lot of steps here. But once we get really good at these guys, a lot of these steps aren't necessary. You can go jump straight from step to step. Okay, so cos of theta minus, do you agree with me, tan of 45, we said is 1 over 1, so that would be a 1. Fantastic. Okay, great. Now, what I'm going to do now is I need to simplify this. So what I can see at the top is I can see a common factor. So I'm going to take minus sine of theta out as a common factor. What am I left with? I'm left with cos of theta minus 1 all over cos of theta minus 1. I can put that in brackets, and what ends up happening here, guys, those end up cancelling, and my final answer is minus sine of theta. Nice simplified answer from that first question. Okay, so like I said, in order to do your reductions and special angles, there is a bit of theory that's needed to be known. Obviously, I'm just going to add it in here quickly so you can see. That was the one triangle we needed to know. We also need to know our 30 and 60 degree triangle, 1, 2, and root 3. Okay, and then also you need to know your co-ratios, guys, and that can be found in the previous videos or in the James book. So any angles that are dealing with 90s and 270s are co-ratios, and they turn into the opposite trig function. So sine and cos are opposites. Okay, great. What else did I need to mention here? Oh, cast diagram. You also need to know that quite well, so that it's also, remember, if you can write this off by heart, it means that you know it. So you know that your quadrants are called 1, 2, 3, and 4. They are also known as the all, sine, tan, and cos quadrants. So all, sine, tan, and cos. And then also they are known as, for your reduction purposes, these names as well. Okay, so we need to know them. There's 3 different types of categories that your quadrants can be called, and these are all of them. You've got your first, second, third Roman numeral naming. We've then got our cast part of the quadrants, C-A-S-T, and then the second one is your reduction naming of the quadrants, okay, for reduction purposes. Awesome, fantastic. Hope you enjoyed this video. We are going to move on to type 2 now in the next video. So please, if you like what you see, please click the subscribe button. And if you are keen for these notes, please let us know so that we can get a James book to you. They are for sale. So just comment in the comments below, or just drop us a direct message and we can get in contact with you. Awesome. Have a great day, guys. Thanks.